This is Euclid Book 3, proposition number 27, and what we're going to do here is we're actually going to cover the reverse of Euclid Book 3, proposition number 26. I know I've been on a little bit of a hiatus, but we're going to start again, and we're going to cover the rest of Euclid Book 3 in the next few days. I will be covering some other topics as well, so bear with me. Here it comes. First of all, we have two circles here. The first one starts at A, comes through to B, comes over here to K, comes through C, and goes back up to A. We have the second circle over here, starts at D, goes through E, goes through F, and comes back up to D. Okay? Now, Euclid says that the circumference between B and C here, you see there's a little line between B and C, that's part of the circle, that's part of the circumference of the circle here. This piece of the circumference of this circle here, which is B to C, is exactly the same size as the circumference from point E to point F. So BC equals EF. Alright. Euclid then says that what we're going to try to prove is that there is the same number of degrees between B, G, and C here, this B, G, and C. There's the same number of degrees in this angle right here as there is in E, H, and F. Okay? So the number of degrees in this angle is exactly the same as the number of degrees in this angle. He then also says that we're going to prove that the number of angles in angle BAC right here is exactly the same as the number of degrees in the angle EDF. How are we going to prove this? Well, we're going to assume for just a second that BGC has more degrees in this angle than EHF. And if that being the truth, then we have to make an angle here which is going to be exactly the same size as EHF. So we make BGK. So we have now angle BGK, and we're now going to say that that angle there is exactly the same size as EHF. Now, if we go on to do this, and we can, because we can use Euclid Book 1, proposition number 23 to create BGK, okay? Remember, Euclid Book 1, proposition 23, okay? And it creates B, G, and K here. Alright. Now we have to go on to say that equal angles stand on equal circumferences when they are at their centers. And this comes from the last proof, Euclid Book 3, proposition number 26. Boing! Alright, if that be true, then we have to say that the measurement of circumference BK is the same size as the circumference of EF. Well, we already said that the circumference of BC is equal to EF. So now we're saying that BK is the same size as BC. And as obvious as you can see here, it's not, because BK is a part of BC. And that's silly, so therefore. Alright. Now that we have established that BGC and EHF are the same size, we can go on with the proof. And the rest of the proof says that because angle BAC, here's B, here's A, here's C, is 1/2 the size, the number of degrees here is 1/2 of BGC, and EDF is half the size in the line of degrees as EHF, and we can prove this by Euclid Book 3, proposition number 20, then finally we can say that angle BAC and angle EDF are exactly the same size. And that's what Euclid wanted you to prove. Alright, there you go, people. I will tell you more in a future video, so stay tuned.